Today we're going to look at lesson 6.3, and the title of this lesson is Solving Quadratic Equations by Factoring. Okay, I want you to look at the steps over here that I have listed that you will need to put in your notes. First step is we need to get one side of a quadratic equal to 0 when you have a quadratic equation. And a little side note there is you always want your quadratic term or your x squared term to be positive. Okay, once you get it set equal to 0, then we're going to look to factor the side that's opposite 0, meaning the side that's still got the variable on it. And then once we get it factored, we're going to use the zero product property to find the solutions or the roots to the quadratic equations. So using the zero product property, you want to ask yourself what makes each factor 0, or set each factor equal to 0 and solve. So add those steps to your notes. You can pause the video if you need to. Then we're going to get started here. So if we look at solving each quadratic, or solve each equation by factoring, if you notice here, you got x squared equals negative 4x. Okay, always locate your x squared term first. In this case, it's on the left side. It is positive, so I want to leave it there, which means I want to get rid of my minus 4x, which means I want to add 4x to both sides. So I'm making the right-hand side 0. So I have x squared plus 4x on the left-hand side is equal to 0. Now, you've learned many different types of factoring. Okay? The first thing in factoring is always check to see if you can factor out a common factor. And if you notice, we only have two terms on the left-hand side, but there is something in common. I can take an x out. So I want to factor out an x from the left-hand side and figure out what we're left with. So if I take an x out of x squared, I'm left with x. This is kind of the opposite of the distributive property now. And then I'll be left with plus 4 if I take an x out of the positive 4x term. Okay? So now, once you have it factored, we're really looking at using the zero product property to find the solutions or the root. What makes each factor 0? So here's a factor, x. Okay, it's not in parentheses because it's only a monomial factor. But you set that factor equal to 0. So take whatever it is, set it equal to 0, and solve it. Now that one is already solved. But if you take this factor, x plus 4, set it equal to 0, to solve that, I'm going to subtract 4, so x equals negative 4. So I get two roots, or two solutions. One is 0, one is negative 4. Let's go to the next example. 3x squared equals 5x plus 2. Locate your x squared term. It's on the left side here. It is positive, which means I want to leave it on the left side. Okay? That means I'm going to have to subtract 5x and subtract 2 to get rid of them here, which means I want to subtract 5x and subtract 2 on the left side. Now, none of these are like terms, so we just write 3x squared minus 5x minus 2 is equal to 0. So we have the quadratic equation equal to 0. X squared term is positive. We want to factor this side now. So I'm going to look at factoring this side. If you notice, that's a trinomial. We cannot take out a common factor. I can't take out a 3. There's no common factor of 3, 5, and 2. Can't take out an x. You still ask yourself that every time. So now it becomes trinomial factoring. And we don't have 1x squared, we have 3x squared. So that means if it's factorable, my first spot I'm going to factor into a 3x and an x. The only way to get 3x squared is 3x times x. Okay, and then I want to go to my c value, my c term, negative 2. And I want to list pairs of factors of negative 2. Well, to get a negative, I got to have one be a positive, one be a negative. So one possibility is 1 and negative 2. The other is 2 and negative 1. Okay, this is trial and error. You got to try something and see if it works. So let's try our plus 1 and our minus 2. Now here's your test. Do your outside, do your inside, combine them, and see if we get the negative 5x, which is this term right here. We want to see if we get that. So I get negative 6x, positive 1x. If I combine negative 6x, positive 1x, I get negative 5x. If they wouldn't have worked, you would have had to switch the plus 1 and the minus 2, try and flip-flop them and see if that works. Just keep trying until it works. So there's how it factors. So now I take and use the zero product property, set each factor equal to 0. So one of my factors is, I'm going to take the 3x plus 1, set it equal to 0, or I'm going to do x minus 2 and set it equal to 0. And I solve each one of those. So here I'm going to subtract 1. So 3x is negative 1. I'm going to divide by 3. So I get x equals negative 1/3. Over here I'm going to add 2. Or x is equal to 2. There's my two roots, one of them being a fraction. And I would leave them as fractions. Okay, let's look at the next example. We have x squared minus 6x on the left-hand side of the quadratic equation equals negative 9. Notice my x squared term's positive on the left, so I want to leave it there, which means I want to add 9. I'm going to make the right-hand side 0. So I get x squared minus 6x and plus 9 equals 0. And now I'm going to factor the left-hand side. So this is a trinomial. We have our a, or our coefficient on x squared, being 1. So this just is factoring where it must be x times x. I list factors of my c value, which is positive 9. Now, to get a positive, it means they either both have to be positive. To get a positive when we multiply, both be positive or both be negative. Okay? So I have 1 and 9, or 3 and 3 positive, or I could have them both be negative. Now, let me tell you some hints here with factoring. And I've said this before, if you've ever heard me teach factoring before. If they're both positive, you can eliminate some ones that you need to try. Whatever the sign is on the x term, which is negative, that means they can't be the positives. So, and we want to just pick the pair that adds up to negative 6. Well, that's negative 3 and negative 3. So it's a minus 3 and minus 3. Notice, both of my factors are the same. So if I set this factor equal to 0 and solve it, I add 3. So x equals 3. Notice the second factor is the same. We don't really have to do that. This one is only going to be one root for your answer, or one solution. Now we call this a double root because we had both the factors being the same. Both of them would give us x equals 3 for a solution. Now there's only one root. It is called a double root because of the fact that the factors were the same up there above. Okay? All right. Greatest common factor. What is the positive solution of the equation 2x squared minus 8x minus 42 is equal to 0? If you take a look at this, it's already set equal to 0. Okay? So, if you notice, I want to factor this side. Notice I can take a 2 out. So I'm going to take a 2 out on the left-hand side. So I'm left with x squared minus 4x minus 21 is equal to 0. And now, basically, if you factored out a constant, if I would divide both sides by 2, that would be gone. This part of it here will not give us a solution because there's no variable. Okay, so really, if you divided both sides by 2, you'd have x squared minus 4x minus 21 equals 0. Really, that constant is gone. So factoring out a constant doesn't have any bearing on the solution. Doesn't mean one of the solutions is 2. It's just you're factoring it out. Factoring out the 2, now I'm going to factor the trinomial that's left there. So it's x and x. I want factors of negative 21, 1 and negative 21, 3 and negative 7, 7 and negative 3, 21 and negative 1. And I want to pick the pair that adds up to negative 4, because again, it's 1x squared, or x and x. There's my pair that adds up to negative 4. So it's plus 3 and minus 7 is what goes in the binomial factors. Now I set each factor equal to 0 and solve. So I would subtract 3 there, so x equals negative 3. Set this factor equal to 0, add 7, so x equals 7. Now, this is a multiple choice question. Technically there are two roots, negative 3 and positive 7. We want the positive solution or positive root, so it is 7. Okay, writing an equation given the roots. Okay, we're going to do this one first. Write a quadratic equation with negative 2 and 3 as its roots or its solution. Write the equation in ax squared plus bx plus c equals 0 form, where a, b, and c must be integers. Okay, meaning positive or negative whole numbers. Now, think about this. What they're saying when these are the roots is that x equals negative 2 or x equals 3. I want you to think backwards from what we did to get the roots. What that means is if the roots or the solutions are these two, think about this. What would have to go to give us a root of negative 2? This one would have to be an x plus 2. Okay, kind of use the opposite sign there, because if I set that factor equal to 0, I'd get negative 2. This one would have to be x minus 3. Okay, and you must have the equals 0 part right here on there. Okay, to be a quadratic equation, you got to have the equal sign. Now, you want it in ax squared plus bx plus c equals 0 form, which means I now must FOIL my binomials together. First terms are x squared, so I'm getting rid of parentheses. Outside terms, so this was x squared. Outside terms would be minus 3x. Inside terms plus 2x. And last terms, positive 2 times negative 3 is negative 6. And one last step, we're going to be able to combine our x terms, so it's x squared minus 1x, or minus x, when I combine those two, minus 6 equals 0. Notice a, b, and c are integers. A would be 1 in front of x squared, b would be negative 1, c would be negative 6. So there's our solution. Alright, last one here. Okay, now this gets a little trickier because one of the roots is a fraction, but what they're saying is x equals negative 2/3 or x equals 6. Those are the roots. So think about this. Think about what we just did. If I want to think about, I got to have the equals 0 part on there, which is a common mistake that students forget that. Okay, really I want x plus 2/3. Okay, we're going to deal with it as a fraction in there. And then on the other one, to get 6 for a root would be x minus 6. Okay, so if I FOIL those together, so I'm going to FOIL now, I get x squared for my first terms minus 6x plus 2/3 x, okay, and then minus 6 times 2/3. So 6 times 2/3, it's like 6 over 1, so it's 12 over 3, or we reduce that, I get 4. So it's minus 4 equals 0. Do not forget the equals 0 part. Okay, we're going to combine these. Actually, before we combine those, because I have a fraction here, I'm going to multiply to get rid of the fraction. I'm going to multiply the whole equation by 3. So if I multiply 3 times x squared, I get 3x squared, because we have to have a, b, and c be integers. So we want to get rid of that fraction. So I'm going to do that before I combine like terms. So I get 3x squared minus 18x. When I multiply by 3 here, the 3's cancel, so I get plus 2x. And I multiply by 3 here, it's minus 12. 0 times 3 is 0. Okay, and then I combine my x terms, so it's 3x squared. Combine these two together, minus 16x minus 12 is equal to 0. So get rid of the fraction, and that would be the quadratic equation that has those roots.